Hi, good afternoon. It's Gene from the Observatory. Just wanted to get over a few things because we haven't talked too much about our magnetometers that are already out in the field, and I wanted to clear up a few things with regards to just two of the magnetometers. First of all, and more importantly, the strange anomaly that we've got going on with one of our magnetometers over in Perth. I'll get into it in a minute, but we've also waiting for some data to come in on M1 from JD in Southern California, and there should be around about 2 months worth of data in that one delivery when it does come. And we want to go back to July when those severe earthquakes happened in South California, and we want to target the date on the day that that large, I think it was a magnitude 7 point something earthquake, and we want to have a look at whether it affected our magnetometer data at that point. So, you know, got a couple of things coming up with regards to that. Want to talk about what's going on in M5 Australia, Perth, that anomaly, and I also want to talk about a bit later on in the video, just briefly, where we are with the Muon detectors and what we've had delivered. And then, you know, I want to get into the topic of what do you do when something globally happens sporadically, and we all know there's a chance of that coming up over the near probably 10 years, may even well be between those 4 to 7 years. What to expect and what will happen, and possibly how it will affect you. So before we get into all this, just a big thanks to you guys that are supporting the observatory. You know, we're an international observatory with our little stations dotted all around the world, as you can see. Most of the data gets relayed back to us in the UK. We process it and upload it to our main website, which is the Poleshiftnews. If you haven't been on there, you know, you'll find all the data that we collect with the trimag, the magnetosphere, and these global magnetometers on that website. So it's poleshiftnews.com. If you've never been on there, go on over and have a look. And there's a lot of other data as well. We've got sea ice extent maps, weather charts, global. We've got radar, satellite photos, which are all updated, some on the hour, even some before that. And you know, we've got a load of solar data on there, cosmic ray, Schumann frequency, a hell of a lot of information on that website, which is always updated live, and you know, just to keep you updated on not just this anomaly that's taking place, but all the others as well. So let's get into it. So as you guys know, last month we was having a little bit of think about what was going on over in Australia with regards to M5 region on this map. That's Jeff's station down there, and you know what the problem was. I'll show you the data in a little while, but what we was getting is like static readings, and it didn't matter where we moved the magnetometer, we was getting static readings again. But that if you moved the magnetometer and the number changed on the left hand column, it meant that the magnetometer was working, but it was like the magnetometer had a magnet placed in front of it, so it was recording the change of movement, but for some reason it wasn't altering or fluctuating like we see on all the other magnetometers that we've got around the world. So you know, it's led to a little bit of further investigation. Jeff has taken it right up to the top of Australia, north as you can go, on the almost on the Tropic of Cancer there, which is a good 2 hours flight from Perth, to see if there's any change, and there's no change there. So I've sent out over the last couple of weeks another magnetometer to Jeff, and what we're going to do is we're going to see what happens when we get those readings. We're going to put them two side by side and see what happens with the data. And you know, it could mean a couple of things. It could mean that the intensity that we're looking at on this map, which was put out by Swarm over in the European Space Agency, has changed. It could mean that that magnetic plume has gone further up towards the equator, or it could just mean that, you know, there is a fault with that magnetometer. But like I said, it's unusual, because if the magnetometer is picking up different locations when it's turned on its axis, then it's obviously doing its job. But the thing is, we see a difference in the data that we collected from, say, California or Kentucky and Hong Kong. There's always that fluctuation over the month of about 2 microteslers, but for some reason in Perth we're not getting that. So it could be that we've got a either busted magnetometer, or there is a new anomaly related to the magnetic intensity down there in the south. And we've also sent Richard on the Gold Coast out another magnetometer as well at the same time. So, you know, there'll be 2 new magnetometers out there in Australia, and over the coming weeks we'll hopefully have the first readings back. Now, if we start to get fluctuation on the new magnetometer that we send Jeff in Perth, then we know it was a fault. If we get static readings, then we've got a new anomaly taking place over that region of Australia. Could be something going on there deep in the crust of the earth and affecting that magnetic intensity. What might be the thing to do then is place a few more magnetometers further east towards the Gold Coast to see where this intensity drops off, and we can get an idea of the shape of the intensity now over the southern hemisphere. But what we might also do is probably put a magnetometer in the Philippines or one of those other islands there to get an idea of how high the magnetic intensity is now and whether it has actually surpassed the equatorial region on this earth. You know, we really need to as well start thinking about probably getting another magnetometer out into India to measure, you know, the Siberian high intensity region as well, just on that westerly side of that continent. Maybe somewhere in Europe, maybe Turkey. You know, we can stretch it out a little bit, and just what we want to do is just find out, you know, get this hammered home, find out what's going on down there in Australia, because there's definitely, in my opinion, something else going wrong. And I'm confident that the magnetometer's not broke, but we never know. But what we're going to do is we're going to put the 2 side by side, take the readings, and if we're getting the same, then obviously the first magnetometer wasn't broke, but nevertheless we're going to have it sent back over to the UK. We'll examine it, and you know, I'm pretty sure that when we get this magnetometer back over here in the UK, the first thing we're going to do is plug it in and get the you know, the screen up so I can read the data off the magnetometer live and see what's going on there. But I believe we're going to get those fluctuations like we do all around the other locations of the world. So there you go, guys. You know, we've not forgot about these things. First of all, M1, we want to find out whether we've got any new anomaly data with regards to those earthquakes that happened in July. And secondly, we want to try and pin down what's going on over in Perth with regards to that intensity region over there. Just briefly moving on to what we've had delivered and what we're waiting for with the Muons. So what we're looking at is the main PCB board that is populated. You can see we've got an Arduino here, LED, we've got the 6-pin jack where the other PCB board joins on there. That's the one that contains our silicon photon multiplier chip. We've got also on here the jack for the or the plug for the OLED display so that we can see what's going on real time, the reset button, the 3.5mm socket which links 2 Muon detectors together in coincidence mode, so we end up with a master and a slave. And then also we've got on the bottom of this board, you can just see the jack coming out there for the Arduino, so if we need to do calibrations we can, or adjust the program, we can. What else is on there? Apart from that, you've got DCD boosters, you can see resistors, capacitors, and a few other little components like, where are we? Well, yeah, I won't bore you with that anyhow, but that's what we've got on there. We've also got a main jack here, which will allow us to plug it directly into the PC so we can graph it live if we want to, which is a good option for doing, you know, just experiments or whatever you wanted with it. What else have we got? And this PCB board we're looking at is the powerhouse of the operation. It's where the sensor is. You can see there we've got the SIP-on soldered onto the PCB board on the back. There's a few resistors and capacitors, and then we've got these hex standoffs which allow this to then get placed onto that 6-pin socket that we saw on the main PCB board. So on the main PCB board we've got all our main front end electronics, and then here we have the sensor of the operation, and of course what's missing from here is the cincellate block, the crystal block that goes on top of the SIPM, which is bonded with a little bit of optical gel, just to give, you know, a nice clean and clear view of the particles that go past there. So what happens is when a particle goes through the crystal block, it creates a spark of light, very, very faint. I believe about 100 years ago, when they first discovered how to use cincellates, there would be some professor probably in a laboratory in pitch darkness studying the cincellate block, just looking for those tiny faint flicks of light that get converted as the particle goes through there. So that's how our PCB board will look when it's populated with all its components. Then finally we've got our third PCB board. We're going to put a logic converter chip on. We're going to mount just a ordinary standard SD card, micro SD card slot, so that we can collect the data onto it, and also there's a couple of resistors and capacitors to put on there. The only other component that I haven't showed you that's got to go on here, and I did in a few other videos going back, was the OLED, and that just simply gets plugged onto our main PCB board at the front with the jack, so it's just a push on. But the only thing we've got to do there is solder the headers on it. So a little bit of soldering to do. I think there's about 12 legs on this, and then another probably 10 or so legs on that, and we've got that finished. So yeah, there we are. We're over here at the poleshiftnews live solar data section, and I wanted to show you the graph I usually do with regards to the levels of cosmic radiation that increases during low solar activity like we're experiencing, but not on today, because as you can see we're experiencing a geomagnetic storm and the KP levels are quite high if you look. So it'd be interesting to see if they increase or actually start to dissipate over the next day or so. But what we will get is a more intense aurora over the northern southern hemispheres of this Earth. What else? I wanted to go down to this chart here. Yeah, as you can see, and it is the main reason why we're putting these cosmic ray detectors all around the world, is so that we can focus on during this trough in solar 24. Okay, let's come back. There we go. If we look at the trough of where we are at the end of this solar cycle 24, you'll see that every time we go through these troughs at the ends of solar cycles, the cosmic radiation increases. The only difference is that over the last 36 years or so, or 33 years or so, of the last 3 solar cycles that you can see on this graph, the cosmic radiation has been spread over a longer period of time, and it becomes more intense as these solar cycles get weaker and weaker. So we want to know what levels the cosmic rays are actually increasing, and we want to know whereabout on the planet these cosmic rays are inbound more so, because the real reasons other than this that we're looking for with regards to the cosmic radiation is the health risks that it poses, and we know it's not set to improve. We haven't reached, in my opinion, and some of the scientists' opinions, we haven't reached equilibrium yet. We haven't seen this start to improve. Over the last 33 years this has been on the increase, and we know that the government organisations aren't being forthcoming with the real results of what they're collecting, to the point where you can't get nothing with regards to geomagnetic data over a level 2 from the European Space Agency that sent up that swarm space mission to monitor the Earth's magnetic fields. Guys, all I can say is that there is trillions of pounds being spent on the research of cosmic rays at the moment, and for all sorts of reasons, and this stuff is on the increase on our planet. I can sort of understand that if they was to come out and tell the truth, I think society would probably stop in its progressive path instantly. And that's why I wanted to get on to the next thing, guys, about talking about what can we expect if we do suffer a major catastrophe as a result of probably some of these anomalies that we look at. And it might come a bit of a surprise to you guys is how fast things will turn around. I mean, we could be all sitting here today, this geomagnetic storm could intensify and as a result completely wipe out our grid. What that means for some that don't know is if the grid goes down, we lose the ability to pump fuel at the stations, so people can't get to work. When people don't turn up to work, that means that every sector is affected. That means eventually, your sewerage is not going to leave your home, and the water's not going to come out your tap, and the electricity that goes into your home is not going to go there for a prolonged period of time. And if it is a result of a solar flare hitting the earth like the Carrington event, then it will not just knock out the grid, it will cause some of these transformers that transport the electricity to our properties and our factories to explode. And we know they don't have a backup for every transformer. We do know that they have taken some precautions, but it isn't going to be enough. Guys, you guys, my brothers in the UK, you know what happens when we get a couple of inches of snow on the roads. It shuts everything down. So if these grids do go down globally, then things will change in a matter of a week, and people will be killing each other literally after 2 weeks. A lot of us don't have food supplies. We are probably the rare few, probably less than 1% of the entire population of this earth that has probably taken some precautions to put up a little bit of rations for ourselves to get us over that main initial period. But pretty much things will resort to how they were back in the days, 1940s, if you look into it, during the blockade in Stalingrad, which is now St. Petersburg. There was over 2,000 people arrested for cannibalism. That gives you some sort of idea how severe things can get very quickly. And it wasn't just that, it gets even worse than that, guys. Nearly 100,000 people a month were dying fighting over food and rations. That's what you've got coming, and it's only a matter of time before it does happen, because right now our primary and secondary field that protects us from those sort of things happening are being weakened. First of all, we've lost 20% of the entire Earth's magnetic field protection, or the strength of the magnetosphere has decayed by 20%, possibly even more. And secondary, we've got a sun going into this low period of output, and it's been doing that for the last 33 years. What this could do is simply send us back into the dark ages, and I kid you not, I'm not trying to frighten you. I'm trying to say that, guys, this is the way it's looking, and if the trend continues to go like this, it's only going to be a matter of time before we see the effects of some sort of major anomaly taking place, which leads to a catastrophe. And we're facing, like I said, more than one obstacle in this gauntlet, and it's only a matter of time. But when it does go, and it doesn't have to be a CME, it could be a lot of other things, but when it does happen, there is very little time to react. If you're waiting for the event to happen and then you're going to make your preparations, you may as well not even bother, because as we've seen will be the case, the only thing that will be on the shelves are the stuff that is not important, and you'll probably end up buying that because you'll need something to trade. So you'll probably end up with a handful of car windscreen wiper blades, as opposed to what you went there for, which was probably a couple of sacks of rice to keep you tied over for a month or so. It will be the case. And there's a couple of documentaries that explain it. I've got a few good documentaries. Nova, the one done by Nova, which talks about the event that we're in right now, the magnetic reversal, is serious enough. It's quite frightening what they're saying, and our Earth could easily be dying right in front of us. That's the simple fact of what we face. And if you think that that is just a crazy hypothesis, then I'll just tell you this. At some point in Mars's history, it had a magnetosphere, and you're probably aware that it had water on its surface. We can see the terraform, we can see the rivers that used to run on Mars. It no longer has a magnetosphere, and it no longer has an atmosphere or water on its surface. It may have small pockets of ice. So okay, if you want to call that water, then that's fine, but I can guarantee you, if our Earth looked like that, most of the diversity of life on Earth would seize, as it has done, most likely the case on Mars. And therefore it is a possibility that our Earth could be going through a similar event. And the reason why I say that, guys, is because the last time our Earth went through a magnetic reversal, it was 780,000 years ago. Think about that, a long time ago. But prior to that, it would go through a reversal every 300,000 years or 350,000 years on average. So something's changed with the core of our Earth in the regular pattern of reversals. This time there has been a delay up until the last 100 years of 500,000 years. That's a 500,000 year delay. That is a long time. So something's definitely changed in the regulatory pattern of our Earth and its magnetic reversals. And that's why I say it is on the cards that we could be looking at something that changes this planet's future and looks forever. So, it's a very serious topic, guys, and that's why, I'm very passionate about it. I'll do as much as I can to inform other people about what is going on. I will go to the lengths of even teaching myself programming electronics to make sure that we build the equipment, because we can't afford to just I can't afford to go to the factory and say, can you manufacture these for me, because they're going to hit me, especially with the likes of the TriMag system. If I asked them to build me bespoke equipment like that, I would have got no change probably out of £250,000. I haven't got the money. The only other alternative left for me was to build it myself and teach myself programming. And we've benefited more than once from that already, and we're going to benefit probably many times from that point on. So it's a God blessing that I did put myself through that pain of teaching myself electronics, because now we've got the TriMag, and it didn't cost £250,000 to develop and build. We've got the magnetosphere sensors, so we're looking first of all at where the magnetic north pole is. We're tracking it with the TriMag every 3 seconds, so a very high resolution. We've got the magnetosphere sensor, which detects the field strength of our magnetosphere. The resolution is slightly bigger than the TriMag, every 15 minutes, but that's perfect because, as we've seen over the last 14 months, it hasn't really deviated a lot. Then we've got the global magnetometers, and very soon we're going to have the which I think is the natural progression and the next thing for us to do, these Muon detectors, which tells us how much cosmic radiation is actually inbound in our atmosphere. And we can also pinpoint where the better areas are on our planet to be during this time where the radiation is coming in more and more. And not only that, a bit later on down the road, guys, we're going to be consulting with some medical experts as to what the risks are with regards to the levels of radiation in these regions, because I want to find out a little bit more about that. I want to really know what it is that causes cardiac arrhythmia and how cosmic rays affect that. And how did they find out that? What was the research behind that? So I'm going to look into that and find out that, and perhaps we can get someone on and do a live podcast with them, and they can explain to you guys directly, so you hear it from the horse's mouth, so to speak. And there's the cloud the cloud chamber that we're building, and that's not far away from being finished. We're waiting for the power pack to arrive, as well as a lot of other components. I think we've got about 12 more components to order to finish off the Muon detectors. Well, not all of them, but at least a good few, so we can get started. And then we've got the power pack arriving shortly for the cloud chamber. And what that does, it gives a visual of cosmic particles or cosmic rays or subatomic particles as they go through there, and we can detect which ones they are by the track that they leave. So we don't actually see the particle itself, we just see the contour trail behind that it leaves, and we know from the angle of it travelling through there, we can work out which particle that was. We might see some electrons, we might see some muons, we might see even some real cosmic particles go through there, and if we're really lucky, we might see a collision. And it's not impossible with a cloud chamber to get collisions of cosmic rays hitting other particles and creating subatomic particles like the muons that we get which is detected by our silicon multipliers, which is the sensor chip or the DIRIS component on the Muon detector. So there's a lot going on, guys, and we're trying our best to answer these questions for you. And yeah, you know, the reality is that this is all real and this is happening. And you know, I just think we need to be better prepared, we need to be better informed, and the only way we can do that is by first asking the questions and then setting ourselves on a course to answer them, like we have done already. And that's why I say we're different to any other channel on YouTube. There isn't another proactive channel like ours on YouTube doing as much as what we are. I mean, we're not just talking about these things, we're actually building the things, and we're building the same things that, you know, these other organisations have invested millions of pounds in, literally billions of pounds. You know, CERN use the same detectors that we use, and the reason why they use those SIPMs is because they're not affected like all other components that do detect these particles by magnetism. Can you believe that? So we felt lucky on that. These aren't affected in any way by magnetic fields. So what a result that was, that we found the right chip, and it just so happens to be the best chip to use to detect these particles. Like I say, the ice cube experiment down in the South Antarctic region, that's using over I think over a few hundred of these SIPMs that we use. This is the exact same method, using singulates and SIPMs, or silicon photomultipliers. You know, these chips, they have like 1,000 little cells in them, and if one photon goes through one of those cells, it gives a reading back through the front end electronics and tells us that it's had a hit of a muon. So you know, we're doing the exact same thing, only difference is, guys, is we're on a micro budget compared to what they've got, and the only reason we can pull it off with a micro budget is luckily because I've got the skills to, you know, put from one project to the next, and that's the only way we've been able to get where we are with the observatory. So, you know, we should all pat ourselves on the backs, and we should definitely say big thanks to those people that have supported us to date, because without you guys chipping in a little bit of money, we wouldn't have been where we are right now. But you know, there is a lot of work to do, guys. There's a lot of money still to spend. It's frightening how much I spent last month on all these components. And you know, you look at the things and you think, like today, when these temperature sensors that get mounted on board the PCB, you look at them and you think, the cost of these things, and look at them, they don't look nothing. But I tell you where the majority of the costs coming in right now, and this is where we're getting hit, is on the shipping. That's where the not the majority of the cost. Obviously, the SIPM was the dearest single component, coming in at about £88 sterling. But then there was, I think, £17 of that £88 was in shipping. So, you know, very expensive. But not on the grand scale of things. When you look at the grand scale of things, what we end up with at the end result is what we want, which is a detector, which, you know, organisations like the European Space Agency or CERN or NASA use, and you know, we've got it working, doing the exact same thing as what they've got. So this is what we have to resort to, it seems, in this day and age, you know, doing it ourselves to find out the answers ourselves, because we've been taxed, you know, for the answers. They've used our taxpayers' money to do these things and not give us back the info. Can you believe it? It's absolutely amazing, isn't it? Anyway, guys, you know, we've got a lot of expenditure to make. You know, I want to thank those people that are supporting what we're doing, but we need to keep it going. That's the short end of the stick. You know, we've got still many things to buy, and the only way we can do that and keep other things going in this observatory is by regular support. And you know, I want to thank all our patrons that have helped us to this point. And you know, if you haven't yet, guys, you know, can I just say, there's a lot of worse things you can do with a few bucks than support, you know, an observatory. So, you know, it'd be great if you could come on board with a few others like there is, and just give us a bit of support. The link's down there if you want to make a one-off PayPal, you know, donation. The link's there, and if you want to become one of our patrons, the link's there as well, guys. But you know, the main thing is, do something to help us. You know, we can get things moving a lot quicker if we can raise some more money. Okay, so there's no need to go on anymore, guys. Hopefully, you know, I've given you a good idea as to where we are with all the things, And you know, as usual guys, I'll catch up with you at some point in the week. Have a great week as always. Bye for now.